Okay, we're going to be going through a bunch of considerations about TAI's impact on economic inequality and how that might be remediated over the next 45 minutes. In the 45 minutes after that, after the break, I'll talk about the long term. Obviously, loads has been written on AI and inequality, and this is only like a very cursory overview. And I'm also no expert on it. I'm, I've been thinking more about the weird long-term stuff that comes later. So chime in if you've got thoughts. Okay, I think that was not quite all supposed to come in at once, but anyway. So we've seen that the impact of advanced AI on absolute wages is sort of ambiguous. It depends a lot on the model, on the degree of substitution between capital and labor and natural resources and the direction of technological development and how much rich people like horses or whatever. Human servants. I think the impact on wage inequality is also ambiguous. You can tell a story in which it widens it or shrinks it via kind of reducing us all to the same level of just being useful for our hands while we have our AI headsets on. But even though today income inequality is mostly sort of about wage inequality because most people get most of their income from wages, in a world of full automation, something that is pretty robust is that the capital share will be really high, and so most inequality of wealth or income will be will just consist of capital income inequality mechanically. So that's the thing to focus on. Already, yeah.
If you rich enjoy this service critically much, they pay critical amounts to that service performed by humans, or I mean the fully automation case.
So I'm saying under full automation.
Oh,
yeah. The tilde accounts for the fact that you don't literally need full automation, because if you have a set of tasks that people can do, but they don't produce a bound-Mills cost distributed effect because the other tasks are gross substitutes, then I would say you don't technically have full automation, but for purposes of determining the capital share, it's like you had full automation. Okay. And yeah, if those bound-Mills effects are too strong, I mean, there's going to be a continuum, of course, but if they're strong enough, I don't really want to be calling it transformative AI. I would just want to be calling it Aghion, Jones, and Jones style, asymptotic, boring AI. So, yeah. Cis-formative AI. No, I don't. So it's already the case that wealth inequality is way higher than income inequality. And note that in an AK economy, the income distribution is just the wealth distribution, because everyone's just earning A units of income per unit of capital that they have, right? In particular, no, sorry, this is not for stock ownership. I don't know what happened. I talk about stock ownership on the next slide. What this should say is the current US Gini coefficient for income is 0.42 before redistribution. I'm just not talking about stock ownership here. Okay? And it's 0.83 for wealth. Do we all know what the Gini coefficient is concretely? It's a measure of inequality, but actually it's got a nice visual representation, which I might as well throw up here, which is, let's say you're going to look at the cumulative distribution of income, or whatever variable you're looking at. Apples, say. So if you before you've counted any people and how many apples they've got, you've counted no apples. And then let's say you add in the person with the least apples. And how many apples have you counted? Well, still probably 0, because there's some people out there with no apples at all. And then you get up to the person with the fewest apples, and then let's say they're at the 20th percentile because 20% of people have no apples. And then you add like the number of apples that they have, and then you start counting, and the question is, what fraction of all the apples out there have you counted? By the time you get to the last person, the person who has the most apples, you've counted all the apples. So this curve here is going to it's going to capture the cumulative distribution of apples once you've gotten up to the 50th, 60th, whatever percentile person, right? Okay. Now, under perfectly equal distribution of apples, the cumulative distribution is just going to be a straight line. Once you've counted half the people, you've counted half the apples, and so on. Does that make sense? Okay. Okay. So the Gini coefficient measures inequality by asking what is the fraction of the triangle taken up by this area. Okay. So if it's one person has all the apples, because you get all the way to the end before you just leap up a little point at the end. So the whole triangle. So it's just like, if this is a 1 unit square, it's just going to be like double the area of that crescent. Anyway, so that's like, it's like 0.42 for income before redistribution, but it's 0.83 for wealth. So if we just sort of maintained the wealth distribution but switched over to an AK economy, the income distribution would get way more unequal. Gini coefficient would, double. In fact, about a quarter of people have wealth that's 0 or like negative. They have more debt than they have assets, including perhaps some people here. If any of you have student debt, that's larger than the assets that you own.
Remaining part, so like whatever I paid, they would pay. So it was going to come out to be like 1 to 2,000.
Sorry, I think someone's whoever's on Zoom, it's a delight to have you, but could you just turn your mic off? Okay. And then, yeah, post in the questions channel on Slack if you like. But yeah, so you get this like one-off sort of like level effect to inequality. It goes up. But now also, wealth inequality can grow indefinitely if people have slight differences in their savings rates. Because if your savings rate's S, the growth rate is SA. Remember that? In an AK economy. So if we've got our separate like estates and you're planting a larger fraction of your rice, you're just going to be growing at a faster exponential rate, fixing A. Recall that, oh yeah, and like another way that you could get wealth inequality spiraling out of hand is even if people have the same savings rates, but the rich can afford some investments that the poor can't because there's like some fixed costs or whatever. You see this already today, right? Like a large university endowment can invest in forestry in a way that like wouldn't really be practical for a small investor because there's some like fixed costs to getting into that. And if larger K means larger A, even a tiny bit, with enough time, even if they have the same savings rate, the people who started out richer will grow richer still at a faster rate. Contrast this with the case of the world as it probably is today, where capital and labor are gross complements. Remember here, if one individual tries to grow faster than everyone else, accumulate their capital stock faster, they can do that for a while, but like in the limit, they're just pushing down the interest rate faster than they're growing their stock of capital. Capital is turning into something like water. It's so plentiful that it's not so useful. So their income, and indeed the income of all capital, will ultimately fall. So you get this kind of equilibration. And that equilibration process that's sort of capping income inequality, at least through capital, like the lid will be blown off it in an AK world. You can just get ever more inequality. So this is a story that Piketty was worried about in Capital in the 21st Century. And again, he kind of thinks this is already an important dynamic. And you can disagree with him about his numbers about the past and still think he might be right about capital in the 21st century after all, because we get the robot. Okay. Okay. So just the shift to capital would produce both a kind of like level effect and potentially growth effect for inequality. Now we're going to talk about stocks, though. So inequality in stock ownership is already quite a bit greater than wealth inequality, probably. Weirdly enough, no one seems to have been able to calculate reliably the US Gini coefficient for stock ownership. But I have a sort of attempt to do that in the endnotes there, and I think it's probably above 0.9. So like the people, like a lot of people own none, and then a few people own almost all the at least public stocks. Yeah, about half of people own none, even indirectly through like retirement savings through their work. And the reason, yeah. Thank you for letting me know. I'm just gonna quit, and I don't know how to quit. Okay. I'm going to share the whole screen. Go here. View full screen. Okay. Is it better now, Tim?
Yeah.
Thanks. So yeah, why is that? Because a lot of people's wealth is not in like public stocks, and the fraction that's not in stocks grows the poorer you are. In particular, often goes into housing. So for the poorest half of Americans, on average, about half of their wealth is in real estate. Almost entirely, that's just their own homes. And that fraction of wealth that's held in your own home declines monotonically with with how rich you are. Yeah, you can kind of look into that. I have a link that spells that out. And housing, when you think about it, is a form of capital that's especially inflexible at kind of like adapting to the times. If the economy changes a lot and you own a car factory, that maybe you can turn that into a plant for making parts for like robots that take advantage of really advanced AI or something. Your house is not going to be anything but a house. And it's negatively exposed to extreme inequality, because if you've just, if you've got like an island, or you've got a, I don't know, there's lots of wealth that like could become more valuable once you have like a few quadrillionaires bidding over all the assets in the world. No one's going to want to pay for like a million mediocre houses, right? So if all the wealth, you know what I mean? If like once the wealth is all concentrated, the relative value of a bunch of middle class or lower class basically solidified consumption. Services providing capital providing a stream of very particular services, housing services for a particular family at a particular income level, is just going to become relatively useless. Yeah.
Like, what if we think that just like the locations are the scarce thing?
Yeah, I mean, so okay, I think that also probably will not be significant, because right now, if you own a bit of land in a city, it's not that the land itself is like what's valuable there. Maybe eventually the earth will like run out of land, and like land will be constrained, but like the people benefiting in those scenarios are the owners of like King Ranch in Texas or something, right? It's not like we're gonna like start like trying to build robot factories on like particular like dense patches of land in San Francisco. The reason why they're valuable is because of the agglomeration effect that comes from all of the like increase in the marginal product of labor for person A that comes from being nearby person B, right? But that's like that's agglomeration with respect to human labor. So if like once human labor is providing very little, like a very small fraction of the value, once we've like fully transitioned, right? Not in the transitional stage where like you need to like.
Not like further over primitive, but you might think some of the value is also just like people valuing being close to each other where there's lots of things to do, and this wouldn't necessarily go away.
Yeah, I see. That's fair. I see. So like the quadrillionaire will be willing to pay for a lot for the penthouse that's like right in the middle of the city, and so if you happen to own that bit of land, or like if you're a poor person in a poor neighborhood in a city and the rich people move to the city. Yeah. Okay, fair enough. Thanks. But anyway, so insofar as like the big generators of wealth or income in the future are like not just capital, but the kind of capital held by public companies, then the inequality story gets even worse because of this. But maybe you can contest that second premise. And then like the final potential source of worry that comes to mind is that inequality in like private companies in general, including AI startups, is even more unequally distributed than in public stocks because, you know, you can't, like, people can't just buy shares or like buy index funds that hold pieces of OpenAI or Anthropic or Save Superintelligence or Thinking Machines Lab or whatever. Now, this last point might not be such a big deal because various analyses, including one famous one by Nordhaus from 20 years ago, suggest that innovative firms only capture a tiny fraction of all the value that they create, and the rest is captured either by just consumer surplus or firms providing complementary inputs. So one example of this is like just looking at the railroads in the past. One source that Arjun made me aware of recently is a book called Engines That Move Markets, but various people have looked at, like, so Nordhaus is asking this question, like, when we invented railroads and built all the railroads, to what extent did the profits that they created go to the railroad owners, and to what extent did they go to the people making all the stuff that could now be like shipped more cheaply or whatever? And so, you know, if all the complementary infrastructure, all the like, you know, the chips and the parts that go into data centers and just all of the infrastructure that can now be run more intelligently with better AI is capturing the value that the AI is creating, then that's kind of a positive story because we can all just buy shares in the other stuff. And indeed, so far, those AI startups have largely been losing money, and the big winners have been the people providing the, you know, the chips and the energy and so on. In order for this to be maintained, though, we might need to maintain this regime where there's stiff competition between the AI startups, and like there can be a tension between that and safety, as we'll discuss more when we talk about tech races on Friday morning. Does that make sense? Like the whole reason why this is presumably happening is that these companies are kind of neck and neck, and that might be a bad story for safety. You might want the winner to be way ahead so that they have the cushion. They have like a huge profit margin, but that means they have the cushion to like go more safely. You want the NASCAR race where the first car is way ahead of the second, and so they take it easy and don't crash. That all more or less makes sense? Yeah.
I had a question. So I just want to understand, suppose everyone has some capital, though some more than the others. Mm-hmm. You have 5 capital, I have 1 capital.
Yep.
If we benefit from the same A out there, we both grow at the same rate, right?
Well, if we have the same savings rate.
Yes, and super exponential rate.
Well, it'll just be exponential if A is fixed.
Sure.
But it'll be super exponential if A grows. Yeah.
Yeah. So why does inequality increase? Because the difference.
So just from this, if we all have the same A, inequality would increase if we just kind of lost our wage income now and made up for it eventually with capital income, just because like the current distribution of capital ownership is more unequal.
Yeah, I'm thinking like.
But it wouldn't increase even further.
You have 5 capital and 1 capital. We both say the same rate, no wage income, and then we just get the.
Yeah. So in that world, I'm getting 5/6 of the income, and you're getting 1/6. I'm just saying empirically in the world as it is now, that's larger than the current difference in our wage income.
Yeah, I understand when I think that way, and then I ask myself, suppose you have 5 robots, I have 1 robot, and then those robots build us anything you will consume. It seems like in this world, the things you will consume increase at the same rate as mine, and then our relative wealth doesn't change in a sense. So it
changes at the beginning because we're now getting all of our income from these robots instead of from our like bodies doing work. So
Yeah.
So it would take rate and be 5/5 well share of the rate.
yeah. So this is what I'm getting at with like the level effect versus the growth effect for inequality. So before we've gotten to this bullet about wealth inequality growing indefinitely, I'm talking about wealth inequality not growing indefinitely, just going up once and then staying constant. Yeah.
All funds or something grouped together. Like if they're all robots and all the same, like
Yeah. Sure. I mean, up to a point, for sure, and that's already what happens, right? Like, if there's like optimal firm size that's larger than any one person can own, well, that's fine. Like, it's not that just Bill Gates owns like a big company and you own a small company. Like, no, you could like all the, in a sense, this isn't exactly how it happened historically, but in a sense, it's like all the poor people pulled together to like collectively own, Microsoft, because like we all own shares in the big company. Um, but at least, also historically, there are some, I think, small ways in which that doesn't always work out. Like with the forestry, I was saying, like, well, why don't we all just get together and buy a forest, right? In the case of the forestry, it's because every forest is different. It's not a commodity. It's not like, with like shares of Microsoft, one's as good as another. And so to overcome the information asymmetry, that like the current owner of the forest will want to like sell you the particular patch of land that's most waterlogged and useless. You've got to do some prospecting, and then so there's like a chain of delegation that makes it a little bit harder for people to collectively buy bits of forestry than for like one big actor. And it's like a really small difference, but it just ends up meaning that like that the rich people, like the big endowment can get is a hair higher than like what you get by just investing in a normal index fund. So and that hair I don't think it's like important right now, but just like it would become more and more important over time if we just have our constant savings rates and one of us is growing a little bit faster. You're laughing, Arjun. Yeah. Show of hands. How many of us have debt greater than asset? You got Dan, the one unemployed guy among us. Okay, well, we'll pass the hat at the end of the lecture. So thinking at like an international scale, this could all kind of hold as well in some way. So Anton Kornek and Joseph Stiglitz have a paper from a few years ago warning that full automation could mean the end of catch-up growth. It's through the kind of channel it's worked so far. The reason being that currently, if you've got a less advanced economy with lots of labor but not much else, not much capital or technology, they can catch up because the first units of capital are especially useful over there. The first like imports of new best practices. But once we can, once it's all just about like robots building robots, those robots aren't any slower at building new robots in a place with like that already has lots of capital than in a place that doesn't have much. You don't have this like pool of some valuable resource, human labor, that can like easily be augmented by the first units of capital. So in an AK world, you're not going to have this channel for catch-up growth. This is true even if everyone immediately gets the same technology. So there's no like issue about slow diffusion of technology, right? Even if the robots that you can get in Ghana or something are just as good as the robots you can get here, they're just going to start out with not very many of them, and they're going to be growing at the same rate, but they're not going to be catching up early. They're not going to have faster growth rates early in time with the robots like augmenting people. Yeah, another issue which could hold kind of at the international or individual level, but maybe is more likely to hold internationally, is this point that you might, like, if there are no tech spillovers or like only slow tech spillovers, then super exponential technology growth is another source of an ever widening gap, an ever widening proportional gap between the people who started out poorer and those who started out richer. I think this is easiest to see in the case of no spillovers at all, right? Like if just, you know, A is going through the roof in one country but not in its neighbor, then you're going to get that super exponential growth in the one country but not the other. But it also holds, even if there's a lag, that itself it's like a constant unit of time. So if as technology advances, the rate at which tech spills over across countries or individuals or groups is itself speeding up, then this isn't going to be a problem. It's kind of like the case where everyone's got the same A. But let's say it doesn't. Let's say there's like a constant lag of time. So it always takes 1 year to learn what the latest technology is from your neighbor or import it or steal it. Then if A is growing super exponentially, the proportional gap between between like AT and AT minus 1 in a frontier economy is getting bigger and bigger, right? A doubles, but then it triples, but then it quadruples. And so if like the developing country always has access to last year's tech from the frontier country, that would be a source of an ever widening gap. And Tom Davidson, actually, there's something I gave some comments on that he was working on. He just posted it today. So fresh off the presses, you can see this argument spelled out in more detail. Yeah.
But you can also have a world where you have this kind of like at first at least where there's no law in which we have like increase of wages and the rate that's so relevant.
Yep.
This might be disproportionately be in like developing countries.
Yep. Yeah, totally right, and it's a great point. Yeah.
The people in the US economy that cannot relocate fast enough and don't have assets.
Yeah, or yeah, the people anywhere. Yeah. So the way I would kind of interpret that, I guess, is that you could have wage compression because now like all of our skills that we've spent all this time investing in are kind of useless, but you know our hands are still useful for a while. Well, it would be kind of an extreme case, but you get the idea. And well, you know, we've got hands, they've got hands. So yeah, so we all kind of we have a time of partial automation during which wages are more equal, maybe income as a whole is more equal, and maybe at the end of that period, the distribution of capital is actually more equal than it is now, because now like we haven't been making that like a huge multiple of what they've been making. They've been saving some as well, and they've been piling up the capital. But then once we get to full automation, I'm wondering what'll happen to the paths from that starting point, right? So yeah, it's a good point that between now and then things could go the other way. But I've just been thinking about from then on, like in a world of full automation, I think you do have a bunch of forces which all do kind of push in the same direction from there.
Once you have automation, what's frozen, right? Like all the differences just become entrenched, and then everybody grows to
with differences in savings rates. I mean, in a way, the savings rates points a way in which things that had been frozen are no longer frozen, right? Right now, something's frozen, which is that you can't outsave everyone forever and get really rich. Yeah. Well, we'll talk a bit about that. I mean, one equalizing. I don't think there are many equalizing forces like just sort of purely at the level of the production function. Once you move to AK, I find it hard to tell a story about why you get an equalizing force. You might get more redistribution because now we no longer have to worry about the most productive people like not working as much if we don't tax them as much. The robots, we can just say, nah, just keep working. So that would be an equalizing force.
On how either the capital or the production from capital is distributed. I mean, I would argue that a big reason like capital, distribution of capital is as it is because of, right, like the owner of the company is the one that has the capital, probably because some information, etc., or no history of entrepreneurship, or which is all right, not stable under automation.
Yeah, okay, fair enough. So maybe what you're saying is like, we're gonna have these robot entrepreneurs, and if maybe they're the ones doing all the entrepreneurship, but if you just happen to get lucky and like start out with a bunch of robots whose bets pay off, then you could make a lot, and your neighbor that started out with a large number of unlucky entrepreneur robots could grow more slowly. So you could get that stochasticity. Yeah, it's a good point. There could be randomness in the system that I'm not accounting for. I mean, I think all of that's already true. Like some entrepreneurs' bets pay off and some don't. And so like directionally, I'd be surprised if that led to a world in which you had like a steady state of more equality or something than now. But yeah, I think it's a good point that I haven't been building in randomness, and some randomness would remain in the evolution of wealth. International. Oh yeah, so right. So I was saying, well, just kind of looking at the production function, I couldn't really see many forces pushing for like more equality after full automation. One exception would be the natural resource share point, that like countries that are just poor now, but have a lot of some natural resource that's like kind of abundant relative to our current quantities of labor and capital. Well, if we have an explosion in like in capital and it's substituting for labor, then the natural resource share could rise. We saw a bit about this on Friday. You could have like a model in which natural resources and other inputs are gross complements, and that's constantly being relieved by technological development. But still, if you have a huge explosion in the other stuff, that could increase the rents on some natural resources. So that could be an equalizing force. Yeah, this is what I was saying. So the like post-transfer distribution of income or wealth could get more equal just because we would no longer, like in all these models, what the planner wants to do is just perfectly equalize income, and they can't do it because people have private knowledge about their own talent, and we have to like elicit effort from them by letting them keep some of the fruits of their talent. Yeah, an argument that actually it might get less feasible to redistribute is that, maybe like the reason why democracy kind of emerged around the time of the Industrial Revolution, or really started flourishing then, was precisely because real economic power, real economic usefulness suddenly became really widely distributed. Like work has actually started being very necessary, and states realized that and needed to like give them more power because they had more like real bargaining power. So Asimov and Robinson have a book making this case from 2009. This is not Why Nations Fail. This is this is a book whose title I can't remember. Does anyone know what I might be talking about? It's The Economic Origins of Dictatorship and Democracy. And Ben Garfinkel has some discussion along these lines from a few years ago as well. Yeah, you kind of get the point. Right now, maybe, the government to like stay in power needs the implicit support of like lots of people, all the ones that'll constitute its army. If all they need is like Musk's support, because he's like providing all the bots from all the Tesla bots that are taking the place of the soldiers, it's no longer the people that have the real bargaining power. It's just like the person. A recent piece on, by Drago and Lane, draw the analogy between this world, which they call a world of an intelligence curse, and the resource curse we currently see, in which countries like Saudi Arabia, where like the state doesn't doesn't need the cooperation of people to like, you know, and like paying their taxes, because they can just fund a full state with a police force and everything by selling oil, can get away with being less responsive to the needs of the people. It's called the resource curse. And you can see how this is kind of the same thing, right? Like the oil in this world is just the, you know, the AI or the very specialized kind of capital that like builds the robocops that might be really concentrated. Just like an oil well, it's just you can just sit on the oil well and extract all the rent. Yeah.
Like excess capacity in like redistribution, like say that one nation produces a lot, but like all the other nations are not rich enough to actually demand the goods.
Yeah, I would think that you could just consume all the goods yourself. No? Yeah, if you think, I'm sorry if I'm not like fully getting it, but I think you don't need to sell what you make to like, you know, you can just make a lot and consume it. The Earth as a whole, there's no second planet, but that's fine. We just consume. But let me know if you think of a way to put the point in a way that will help me understand it better. I think this worry is sometimes a bit overstated. Like there are already countries that, or states that get a lot of their revenue, their state revenue from natural resources, but like because we locked in a democratic order before that happened, it was able to persist, right? Hopefully we can make the same happen for intelligence. Yeah.
Just redistribution, like not like Saudi Arabia does a lot of that. They don't do democratic redistribution.
Yeah, that's a good point. That's a good point. Nevertheless, for people who do worry that like right now the people have power because they have real economic power, but that could fail to continue in a world of advanced enough AI. One proposal that like Anton Kornek in particular has really been pushing for is a sort of seed UBI. So the idea is, you know, once people have sort of lost their power to Elon Musk in the future, we won't be able to pass a UBI. The people with the real power can block it. But maybe we can sort of lock in a sort of seed UBI now, which scales up over time and kind of keeps wealth equally distributed as automation advances. We already, I mean, kind of have that. Like we have like earned income tax credits and stuff that like would mechanically grow as people sort of as unemployment became more prevalent or something. But we could definitely kind of go harder on that. All right. Yeah, this seems kind of much more feasible within country borders than across country borders, right? Obviously, there's no current mechanism for like a seed UBI globally, right? But maybe we should be working on it. Okay. Yeah.
Why does the seed help? Or did Elon just cancel the UBI? That's where he says.
Yeah. I mean, you know, it's a sketchy plan, and if you take this argument seriously enough, then it's not going to work. You'll need to have some story that like, you know, canceling a program that's already where the infrastructure is already set up, and you know, it'd be very easy to muster outrage for trying to cancel it and all of that. Like the cost of overturning that would be higher than the cost of blocking someone from setting up the infrastructure and creating the norm of like widespread redistribution when the time came. I mean, what are you gonna do, right? Like if, yeah, I don't know.
Well, I mean, like one reason why kind of like you might have outcomes like I don't know, Dubai or something where you have just like have endless resources just like redistributed to everybody is that at the end of the day, right? People still have the power of just like they can just rebel, whatever. But I mean, I think there is evidence, but like there are even papers on this that kind of AI can help suppress or manage, right? Like population or like
Yeah.
A lot more effectively, and then you don't even need that, right? And you don't need to appease people like even be part of it. But I
Yep.
Or you can
Yep.
straight up dictatorship.
Yep. Yeah, I guess I was trying to sort of gesture at that with this point, right? That like you were saying people could rebel. Maybe before that, people could just not enforce, right? So like if, you know, all the cops or soldiers or whatever, if either you're pressing them or like all their families and friends and so on, then it's going to be harder to get them to you know. Okay, well, we've just been talking about inequality of income or wealth rather than welfare. And those can be very different. That's part of why I thought it might be helpful way back at the beginning to go through this exercise like on the relationship between the two. So in particular, if people have isoelastic utility with eta greater than 1, then as long as we all have unbounded consumption growth, so no one just like gets stuck at some finite level of consumption, then welfare inequality has to go to 0 with time, right? Because just like the general point is if you've got an upper ceiling on utility and we're rising toward that ceiling because C is growing, then all the dots on the curve are getting crowded up around the ceiling, if you just imagine that, right? So the absolute gaps between the dots is going to 0. Peter's looking confused. So like, this is C, this is U of C. There's just a max. Like, you know, even if one person's like, you know, shooting off to infinity and the other person's like only slowly having their consumption grow, if you just kind of come back after 1,000 years and see how they're all doing, they're all going to be at this level of utility base.
Yeah, but that assumes their consumption's everyone growing, which is that's the whole point of inequality.
No, I said as long as we all have unbounded consumption growth, right? And that's absolutely not the whole point of inequality. Inequality is different from the absolute like level of consumption that people have. I'm just saying, like, you know, there's a question of if utility is linear in consumption, then you could have all this inequality because like some people their consumption is growing really fast and so their utility is growing really fast. Other people, they're just crawling up. You know, you can still think that's a problem. Utility is getting more and more unequal.
Yeah.
No one's destitute, but it's just like a foregone opportunity for an equal society that would have, you know. I'm just saying in utility terms, if you've got this upper bound on utility, you get the equal society and welfare, even though you've got the really unequal amount of consumption.
Yeah.
They're just
The whole society has to get it.
yeah, but it could be slow. But in the long run, welfare inequality will be shrinking. Now you might worry about inequality anyway, despite this observation. First off, because you know you might think that there isn't this ceiling. You know, you might think that the relationship is more like linear or more like square root or whatever, like I was just saying. Or you could think that at any given point in time, there's a cap on how well off you can get as consumption goes to infinity. But then, like, you know, as I've said a few times, maybe over time the ceiling keeps sort of rising, and functionally that's more like the case in which you have an unbounded relationship between consumption and utility in the long run. Yeah, so and yeah, depending on the shape of the function, it could be that like even constant consumption inequality leads to like ever widening utility inequality. Because as you get richer, the constant consumption gap leads to a widening utility gap. Of course, as you were saying, you could also worry that even absolute incomes for some stagnate or fall. You know, an optimistic story about the AK world, of course, is that as long as people own some capital and save some fraction of it, then this shouldn't happen. Like you need a reason for why this wouldn't happen, but it might not. In which case, they could be badly off even in absolute terms. Yeah, even if incomes just stagnate as opposed to falling, it's still just a big foregone opportunity if there are these people that they're like fine, but like with the right redistributive policy, they could have been, they could have been really well off. This is what I was getting at before with like, the government just being beholden to Tesla or something, but there is this political economy point that people have, worried about for ages, including Stiglitz, to name one name among many, that even if at first you have just the point that like everyone's income's growing, but the incomes of the wealthy are growing way faster, that tide could turn if like inequality early in time leads to some sort of change of institutions that lets the power get locked in, and then like the rich can expropriate the poor and no one can stop. And yeah, that could like have an effect on short-term inequality, but could also have an effect on like the whole course of the future if values get locked in, and you're left wondering, whose values you think would be better for the whole for the long term, those of like today's median voter, those of the the owners of the bots. All right, scattered thoughts on how bad inequality is. I'm taking quite a bit longer here than would be ideal, as usual. So this is something I've just been thinking about recently, but I think it's a good time to introduce the idea of the value of a statistical life, or a value of a statistical life here, because it'll just be so relevant to Chad Jones's talks tomorrow morning, and some of you might not be familiar with it. So first, so the context in which I'm introducing it here is just a narrow one, but this concept has many many applications. The application here is, suppose you want to measure utility growth over time, but you don't know the shape of people's utility functions, and that itself can change over time. So from period to period, the function from consumption to utility could be arbitrarily different. You observe the consumption, but you don't observe the utility function. As long as the utility function is differentiable at each point in time, not necessarily differentiable like with respect to time, but in consumption it's differentiable at each point in time, you can use the value of a statistical life, or in particular of a statistical life year. And this will be the formula for how fast utility is growing. But first, what is the value of statistical life? So here's a nice visual representation. So if this is consumption, this is utility and consumption, you need a length of time that you're thinking about in principle. Let's say this is like consumption per year. Then we'll say that this is like how much utility you get, like if you integrate over the course of a year. It's like how many utils you're racking up per year. The value of statistical life is the answer to this question. Let's say someone's consuming this much, and you're asking, how much of a loss in consumption for them is just as bad for them in expectation as, say, a 1% chance that they die, and then multiply that by 100. Or how much money do you have to give them so that just compensates for a 1 in 1,000 chance that they die, multiply that by 1,000. Now, let's say it's 1%. You'll see like the limit of that, as we go to 10,000, a million, the limit is going to be the value of a statistical life, or life year. So they start out here. The amount of consumption that they have to lose. So let's say we're asking about 10%, okay? So they get this much utility if they live, for sure. And if they suffer a 10% chance of death, then this is their cost and expected utility. If like 0 means death. Okay? So we're just asking like, how much consumption do you have to give up to be indifferent between that level of consumption for sure and like a 10% chance of getting death and a 90% chance of getting, no death. Just, yeah. Okay. And then, so that gets you down to this much expected utility, like 0.9, expected utility, either way, through the loss of consumption or through the chance of death. And then if you multiply that by 10, then, with every step, you're going to be, like if you just extend the line, so because if you're multiplying this loss of utility by 10, you're going to wind up down at 0. So this gap here is the VSL, or I'll say the value of statistical life year. The value of statistical life year would be the answer to the totally unrealistic question, what if you had to just give up a year? So we resurrect you at the end of the year, okay? Does that make sense? Because this is how much consumption you have to give someone for them to take a 10% chance of dying. But to get to kill someone for sure, you've got to rope in 10 people and pay each of them this much to compensate them. And so if you just multiply that by 10, this is the answer to that question. You're multiplying it by 10. It's this much per person. And then as you take the limit, it's it's just going to be like you're going to take the derivative here and multiply it by that. So u prime of c times it is going to be so rise is u of t, run is u prime of t. So the derivative is the slope times the length. Okay. That's going to equal, what's that going to equal? Nope. Nope, it's very simple. This is the slope, and this is the base of the triangle.
Like the height.
The height. Come on, guys. The height. If you're rising at like one, at a gradient of like 1 unit per, or like half a unit. If the slope's a half, you're rising by half a unit per unit you move to the right. And if you move to the right 10 units, that means you've risen by 5. So like the slope times the base. So so this is going to equal the actual level of utility, right? This is the actual number of utils we've got. Yeah? Jack?
Explain why this.
Sure. So, okay. So let's say, so the value of the statistical life year is the answer to the question. Let's say you take someone and you're like, how much consumption, for how much consumption would they have to lose to be indifferent between losing that much consumption, okay, and getting down here, and having a, say, 10% chance that they die, and then you multiply that by 10. We're going to imagine taking the limit of the answer to that question as you kind of say, okay, what about if you just ask how much consumption loss is equivalent to a 1% chance of death, and then multiplying that by 100? How much consumption loss is equivalent to 1 in 1,000 chance of death, multiplying that by 1,000? The reason why the limit of the answers to those questions is going to be this is because the amount of the amount of consumption that they have to lose to be indifferent between losing that much consumption and a 10% chance of death is the amount of consumption loss that lowers you by like a tenth. So then I get like 0.9 utils compared to if this was 1, you know, for sure. And then that's, you know, if I get 0.9 utils, that's the same as a 10% chance of death. Right? Okay. And so that much less consumption lowers the level by like a 10th. And we're going to be multiplying that by 10. So multiplying that amount of consumption by 10 is going to get you down to 0, because like you're losing 0.1 utils per move to the left. No. We're saying like, let's say you just go up to someone and you say, here are your options. You lose this much money for sure, or with a 10% chance, you die and you get 0. Or at least you die for a year and then you come back at the end. Okay? So that gamble gives you a 10% chance of this and a 90% chance of that. The amount of consumption that's going to make them indifferent between that amount of consumption for sure and the gamble is going to be this much consumption. The amount of consumption that gets them 0.9 utils for sure, which will be this amount of consumption. Okay. And so that amount of consumption times 10 will be this, because it'll, with every move to the left, you're falling by 0.1 utils here. So you just move like 10 times to the left. Okay, so if you're not familiar with this and with the value of statistical life, then kind of stew on it, because it'll be relevant for thinking about how much we should be willing to spend for safety to lower the chance that people die. And that's kind of the big topic of tomorrow morning and indeed the rest of tomorrow. But then just kind of as an aside, an application here, it turns out when you think about it, is that since we've got this equation, we know that the growth rate of utility will be the growth rate of the VSLY plus the growth rate of the marginal utility in consumption. Does that make sense? And this will be the rate of pure time preference minus the nominal interest rate. And you can think about that if you like, or I can talk about it afterward. But the important thing, I think, was I was just looking for an excuse to slip in like what the VSL. Anyway. So yeah, so if you have the data, then ideally to just track welfare inequality, you could just, you know, if everyone's facing the same nominal interest rate and has the same rate of pure time preference, at least, you can just sort of track their differences and like how much you have to pay them to endure a chance of dying. There's this widespread hope that once we get rich enough, or when some people get rich enough, inequality won't be a concern, and at least certainly like some people being below subsistence won't really be a concern, because it takes only a tiny bit of charity from the people at the top to solve all the world's problems. And, you know, I think you kind of see this dialectic play out pretty clearly in this one interview with Demis Hassabis, where Demis sort of presents this abundance thought. The interviewer says, well, hey, we already kind of have a lot of abundance, but don't distribute it that much. And Demis says, that's because it will require people to make sacrifices and people don't want to, but things won't feel so zero-sum with the radical abundance of AI. Just off the bat, I mean, without even thinking about utility functions and stuff, I feel like there are a lot of billionaires now that I don't think, it seems to me like they're not giving their money away, even though it wouldn't really require sacrifice. But anyway, I think implicitly the model at the back of a claim like that is a sort of satiation-based one, where you know, you've got like a selfish part or like a consumption utility part of your overall utility function, and you've got a budget constraint of A, which you can allocate between the consumption and the charity, which is Z. And even if alpha is really, really low, if A is high enough, then you just sort of want to switch over after a while from consumption to charity. Right? So before that, I think kind of some thought along those lines is what is probably what people are thinking. And that would tentatively be supported by looking cross-sectionally at philanthropy today. So like it's sort of U-shaped, but that means that at least at the upper end, it's a luxury good. So people making $0 to $200,000 a year in the U.S. Have this U where like they're giving away 3 to 4% of their incomes at the bottom end, only 1 to 2% in the middle class range, and then it goes up to 3 to 4%. But then above that, it just sort of keeps rising. And then, yeah, there's this giving pledge where 13% of US billionaires have pledged to give at least half of their wealth. But that's non-binding, and I think currently they're not really on track to. And also, it's only 13%. But anyway, what? It is sad. Longitudinal, yeah. What's up?
Well, and like a lifetime utility you have in mind? You wrote the U of ANC.
I mean, I am thinking of flow utility. Right. Indeed. Well, that's kind of where I'm going, maybe. So that's a good point. I wasn't going to think about life extension in particular, but I was going to think of just like more ways to spend money over time. And obviously, yeah, if you can like live longer and longer, and each extra year of life maybe costs more and more, and I don't know, yeah. So yeah, so if the model of the previous slide were right, you would expect that as people got richer over time, they'd be giving more to charity. But that's not right. So for like 100 years now or something, people in the US have been giving like 2% of their incomes to charity. In fact, if anything, it's been falling these. And that might be because as time goes on, we create more ways to spend on ourselves. And that could take many forms. My like new product story, obviously I keep going on about it, but another one would just be like you could buy more and more years of life or something. But the general point would just be that technological advances raise your consumption utility. Also, yeah, like if people are like playing status games with each other or something, that like Zach talked about external habits. That's what I'm calling keeping up with the Joneses, or just like habit formation for yourself. Also can, it can be a dynamic playing out over time that mean that in later times, even though people are richer, margin utility on their own consumption is higher for them. So that would predict like that would like offset the other force pushing for more philanthropy over time. Yeah.
Maybe I'm looking at these numbers wrong. The philanthropy roundtable stuff feels inconsistent with the 2%.
I think just most income is in the middle there. So that's like part of the story. But another part of the story is that, yeah, I mean, thanks for raising this. Another part of it is that some sources are looking at like income on tax returns, but a lot of people like will say in surveys that they give more than they report on tax. Yeah. Well, but like especially kind of at the bottom end, like people might just not bother reporting if they're paying no taxes, right? Sure. But it's, yeah, probably a combination. But anyway, I think basically even if there's a bias in some ways of estimating this, we generally just are not seeing a trend. So that's kind of the important point. But how bad is that? Because even if you just have like a constant amount of voluntary redistribution, that'll still generate widespread abundance after transfers, and indeed it'll impose a lower bound on inequality, not just like a absolute poverty bound, but like a bound on the Gini coefficient, depending on who's getting the transfer. It won't equalize economic power or anything, but you know, at least it'll prevent us all from starving. In the extreme case where the wealth of the majority before transfers goes to zero, another issue is that for us all to be kind of back at our own standard of living off like the 2% that they're giving away, that'll only get us back to where we were once their wealth is like 50x what it currently is. You know, so you could have like a big gap in time, you know, generations where the standard of living for most people falls. We can't just kind of hope that philanthropy immediately picks up the tab. Yeah, this was all supposed to be like the first half of this afternoon's lecture, and I do want to get to the other half. So I hope it's all right if I just plow through and then we can chat after it. Yeah, sorry for being too ambitious as usual here. Here's a crazy thought, though. So if you're really zooming out and looking at like the whole arc of history, well, you know, people give less to those more politically, geographically, biologically distant to themselves. So only 10% of that 2% from Americans is going overseas. Tiny fraction of a percent is going to farm animals, wild animals, basically nothing. Not like wildlife preservation, but like actually trying to like, you know, improve their welfare. Yeah, these endnotes, don't worry about that. Okay, and when you think about it, like, well, political separation often begins as some sort of inequality between groups. It gives rise to like different political interests, and maybe some, you know, group like secedes from the other or kind of starts a new colony elsewhere or something. Speciation ultimately started out as like some group kind of leaving its, you know, the other like colony of baboons or something, and, you know, kind of going off and forming a new society on its own. Even though looking at recent global history, you see catch-up growth across countries. I don't think anyone's really hoping for catch-up growth across species. And so, I don't know, I feel like in the extreme, you could just imagine like the giant triangle that leaves, you know, some species totally unadvanced and some countries, you know, not catching up. Just sort of, you know, just widening and widening, and we could all end up being like the sort of wild animals, as it were, to a population of elite cyborgs that are all philanthropic to each other, the way Americans are to each other, but everyone else is left out in the cold. I don't know. Anyway, all this is to say, you know, if you zoom out far enough, like we shouldn't just extrapolate it some trend of like, oh, you know, philanthropy is always 2% or something. There are these proposals people have floated to lock in some corporate redistribution in advance. So yeah, we might want to encourage companies to include a sort of windfall clause thing where if they get really, really profitable, just such that their profits are a large fraction of global GDP or something, they'll give a lot of it away. Cullen O'Keefe had this interesting idea that this actually might be in their interest early in time when it seems really far-fetched that they'll ever get that profitable, because just as for the same reasons that like a little bit of corporate philanthropy or like corporate social responsibility is considered good practice for just like kind of public relations and so on. It's like small ex-ante commitment, but then, you know, in the crazy scenarios, it really kind of benefits everyone. Yeah, that's what I was saying there. This could also kind of help diffuse a technology race, because you're not going to be thinking, oh my gosh, I've got to beat my competitor or else I've like lost the whole world to them. No, like if they've somehow credibly committed to just redistributing a lot of their profits if they get them, then you don't care that much who wins the race, and that might make the world a safer place as well. So OpenAI's governance structure originally kind of build something like this in, because investor returns are capped at 100x, and the residual all goes to this nonprofit whose mission is to ensure that AGI benefits all of humanity. Of course, it can be challenging to lock plans like this in, and it gets more challenging the closer we actually get to one of the crazier scenarios, because like the commitment is no longer small present value and expectation. Once a lot of investors are actually anticipating those huge profits, then the cap is going to actually deter a lot of investment or shift it over to the competitor that does not have that cap in place. Yeah.
The idea that it's small, that's the top wall. Doesn't realize that it's a big.
Well, I think Cullen's original idea was that it just might be small because it's genuinely unlikely. So, I mean, if ex ante, as of 2020, he was thinking there's like a 1 in 1,000 chance that OpenAI ends up really knocking it out of the park, then like for most investors, they're correctly anticipating this. Yeah. But might as well.
Just as good as a big commitment to something small now.
Yeah, but it might be like within the CSR threshold of being something that a company could actually like get away with. Yeah. And of course, yeah, this will be like hard to enforce, especially if conditions change. We all know that like, OpenAI's nonprofits' actual control over the company has sort of a fraught history, and they recently almost converted to a for-profit. Okay, if we're going to try to redistribute, broadly speaking, how are we going to do it? We could try to actually shift technological change in a way so that people stay kind of augmented rather than replaced. Obviously, this is great if it works out because sort of real economic power is more widely distributed. Maybe there's some value in the fact that we get to derive satisfaction from knowing that we're like contributing to the world through work. I think as implemented in practice, this would probably mean actually foregoing a lot of growth because we're not like relieving that bottleneck that comes with only having so much labor. Technically, it doesn't have to, right? So just for a thought experiment, you could imagine like a fully automated underwater city built so that each person's unique fingerprint is needed to plug a hole for 1 minute a day. That would be a world in which the marginal product of labor, that tiny bit of labor, is massive. It's like the whole city. So people have a lot of real bargaining power, but the growth is kind of not constrained by the lack of people. This is very closely analogous to that Mukherjee and Ray type model from lecture 5, in which growth is sort of unconstrained by a lack of labor, but the labor share stays high because people are kind of a bottleneck to like turning bots into consumption. Remember that? It's kind of analogous. But naively implemented, or like even just practically implemented, I think there is a real trade-off between like maintaining a high labor share and there being a lot of growth. So obviously, like the main thing you'll hear people call for is just like a ban on useful AI applications to protect jobs. That's clearly foregoing growth to maintain a high labor share, which makes it hard, potentially undesirable, and hard to implement at like a national level when you're like competing with other countries that might not forego all that growth. I think, yeah, just kind of there's just not a great historical track record of actually maintaining super inefficient directed technical change. And there's a con on the flip side of that, which is that we still have to work. Maybe we don't want to work. Okay, so what about a UBI? There's this distinction between redistributing income and having capital widely distributed. It's sort of a distinction without a difference, I think. There's some subtle differences, but if people kind of own capital, they have more direct control over the companies in question instead of only indirectly controlling what companies do through the democratic process because your country controls the company. You can just own shares in the company and like do shareholder activism. Whatever. You can take a look at this. There's a paper that asks the question, how much automation will we need before a full UBI at like current standards of living becomes affordable? Unfortunately, on my reading, this particular paper is full of mistakes, but you can check it out for like the framework of the problem and try to do something along the same lines. There's a widespread worry that UBI will leave people miserable and unfulfilled. On my reading, basically, there's just no evidence for that at all. There's been loads of studies of UBIs now at different sizes in different countries. Not any that's like looked at what happens if you try to give someone a full like modern middle class standard of living, so they don't have to work at all for that. But basically, all of them across the observed range find decreases in like pretty much every index of mental ill health. And you know, another pretty consistent finding is that in people, well, yeah, in a lot of cases, people do still work just as much as before, and it kind of makes sense. You're not taking away the option to work. People still like, you know, at least some kinds of work.
I thought the Boltonall paper, they looked at their evidence they didn't get.
Yep. So these are the studies that found positive impacts. The Vivault et al. One was not on this list, right? They looked at sort of just self-reported well-being, rather, and there they didn't find anything, but they did not actually ask about like mental health.
I thought they had questions about like stress, like maybe not directly.
Okay.
Was there like a second study?
Yeah, I thought they had like an question.
Okay, I should maybe look into that more closely. I don't think they have explicit mental health questions, but they might have things that are basically mental health questions, and I should have included it. Also, this says life satisfaction / mental health, so sorry about that. They have mental health questions. Okay. All right, well, maybe I'm thinking of earlier draft or something. Okay, good, thanks. My understanding is that you, in the same way, you get inconsistent findings on job quality. So you might think that people get to shift to work that maybe, you know, pays less but it's more enjoyable or something. Some studies find no effect, and some find a positive effect. That's my understanding. Okay. Then you might kind of speculate about how this would change in a world of a UBI in TAI. I think, like, you know, some things to just chew on to the fact that, like, you know, many groups today are unproductive but happy, right? Like, if we're all just like retirees in the future, I don't know, that doesn't seem like the end of the world. Obviously, post TAI will presumably have much better entertainment, including like literal wireheading and stuff maybe. And finally, you know, I just think it's like, it's kind of funny, like we're able to imagine like radically technologically different futures in which, you know, there's no more death, no more aging. And yet people sometimes worry that we still have like workaholism, and you can make up your own mind, of course, but that seems very pessimistic to me. I think we can probably learn to enjoy leisure if we try. Okay. So I don't have nearly enough time. I don't know where the time went. I mean, it's just, but now I'm going to talk about like all of the whole future, like half of space time. That's the future. I'm going to do that. All right. So briefly, I think I'll just jump to here. So there are three differences between the way a classical utilitarian would answer normative questions and the way they're kind of most often answered implicitly in like an econ paper or an econ seminar. One is whether you discount the future due to like pure time preference, not just uncertainty. One is whether you think that larger populations sort of proportionally count for more, or whether you just kind of don't really engage with that question that much to begin with. And the other is whether you like explicitly kind of count non-human entities that can feel pleasure and pain, or only count the humans. So as a proud classical utilitarian myself, I like to call these the three sins of economics. But more generally, I think it's good to know about them to understand the roots of some disagreements that people will get into online or whatever about how to weigh various like big picture costs and benefits of TAI. So thinking about like, you know, how much growth to give up to lower X risk a bit or something. Yeah. So briefly to just like, well, no, there's no time. I'm not going to get into why you might believe one normative position or the other. I'll just sort of note that those are three distinctions. Note that all three of them come up in this classic Bostrom astronomical waste argument for caring a lot about X risk. Bostrom points out that there could be lots and lots and lots and lots and lots of lives in the future which are very efficient, because if we're like simulating mines, then with like a little bit of energy, you could create lots of experiences, which maybe they're very happy experiences. And he concludes from this that, well, on the one hand, there's a lot of value in speeding technological development, because we're going to reach the day when we are turning all of the energy out there in the stars into happy experiences sooner than we otherwise would. And there's so much of it that counts for a lot. So for every second that we delay our path to that glorious future, we're losing 10 to the 29 potential human lives, or like human equivalent simulated lives. But he's like, okay, so growth is great, but X risk reduction is even better. A single percentage point of X risk reduction would be worth delaying for over 10 million years, because when you speed up, you just kind of get the extra kind of, the gravy on top. We're on this great path, and you speed up, and the path is nudged up by a hair. But if you reduce X risk, you're getting the whole area under the curve, and that's a lot more important. And he concludes that for, I would say, classical utilitarians, priorities 1, 2, 3, and 4 should be reducing X risk. So that's his argument. Problem with it is that's completely invalid. All it shows is that reducing X risk is better than speeding growth. But there could be lots of other ways to change the shape of the future. And in principle, we haven't ruled out that those are even better than reducing X risk. There's this more careful argument from Graves and McCaskill in 2021, which goes like this. So let's say you accept the premise that the cheapest way to increase welfare, or perhaps just human welfare, in the next 100 years is to give to malaria charities, and that doing so saves 0.00025 lives per dollar. Those were the latest numbers from GiveWell as of 2020. Let's say you believe that. And let's say you also believe some research from Toby Newbery that given the distribution of asteroid sizes and speeds, without any intervention, X risk from asteroids is about 100 million per year. So like 68 million years ago, you had the last big one that killed the dinosaurs. Well, they come around about once every 100 million years. And again, from that Toby Newbery research, you can try to say, okay, we know about how much we can lower this number with like our current technology for trying to deflect asteroids with more advanced warning. And we know how much more advanced warning we get per dollar by giving to at least these two places, the B612 Foundation or the Planetary Society. And so we know that we can reduce asteroid X risk by about 5 times 10 to the 18, 10 to the negative 18, like units of probability per dollar. And so even on they argue, conservative estimate of the number of expected future people given no existential catastrophe, this works out to there being an expected benefit of 3,000 lives per dollar to giving to one of those places. And that, since all that benefit accrues after 100 years, basically, an expectation, then as long as you think that those lives are going to be no worse than the lives you're saving from malaria, and that they're both positive, they're both like better than non-existence, then it actually fully logically follows that any use of money that's within some, say, you could pick 1%, 10%. Any near best use of money overall must be near best with respect to the long-term future. Okay. I mean, like, let's say there's like one use of your money that's like the very best one. It has the best impact on the world, full stop. That would be like the best. And then near best means like you get within 10% of that. Okay. This is just like a matter of algebra, and in footnote 6, you can see it spelled out. But like the best thing in the short term only does this much, and the best thing overall does that much, most of which is in the long term. So if you're going to beat that, you've got to be beating it in the long term. You can't be beating the short term, because if you were, you'd be beating GiveWell in the short term, and by premise 1, that give well is the best thing for the short. Okay. So just to clarify, this isn't the case. This isn't making the case that asteroid deflection is anything close to the best use of money. It's just sort of a clear and unambiguous lower bound. Does that make sense?
Yeah, I was going to say, like, the last slide does depend on your population model, because there is sort of knock-on effects of someone dying.
No, this argument doesn't rely on that at all. Premise one, that's actually what I'm going to say. So the claim is not that what's near best for the short term can't also be what's near best overall, because you could think, and some people have a model arguing, that saving lives today, say from malaria, also has a huge long-term benefit. Okay?
Yeah.
Right. So, but that doesn't contradict either premise, right? Yeah. So the claim is, in terms of just ways to benefit the next 100 years, this is, yeah. Okay. Now you could certainly challenge the premises. The conclusion follows from the premises, but people have disputed them. You can also accept the conclusion without accepting the premises by getting to it through other paths. What does this imply for TAI? Well, it means that the kind of very immediate implication is just that either you shouldn't be doing anything TAI related at all, at least with your money, or you should be, but you should be doing something that's going to be near best for the long term. Now, more concretely, let's say we've got a utility path. Let's let UT denote the sum of utilities across people at a given time. And suppose that there's some T underline such that anything near best overall is near best for the future from T underline forward. So trivially, this is going to hold for T underline equal to 0, right? Anything that's near best overall is near best for like the whole future, because you haven't restricted your scope of attention at all. But let's say it holds for some T underline greater than 0. Let's say that absent some intervention on your part to like lower X risk or whatever, the probability that we survive past T underline is S. Okay, S for survival. And that the utility path given survival is that. Okay? And suppose that there's some exogenous T overline less than infinity where we'll end. So like this is what the utility would be at each point in time if the world never ended. But we'll actually only get to enjoy that path until some T overline. Okay. You with me? Okay, so then we can divide the space of impacts on the future as follows. So we could like raise or lower near-term X risk. That is just like changing the probability that we make it past T underline. The long-term benefit, which we can take as a proxy for the overall benefit, will just be M times what the utility path offers from T underline to T overline. Does that make sense? We could advance or delay growth, by which I just mean like the whole utility path, the whole like trajectory of civilization, by K periods. So that is, we can swap out our U path for a U tilde path, where U tilde T, the like amount of utility we're getting at T, is just whatever we would have been getting at T plus K. We just sped things up by K. You just kind of speed everything up. And now on the new path, in 2050, the world just looks the way it would have looked at 2055, if K is 5, say. And then I really just didn't put the slide breaks in very well. The long-term benefit will be just the extra utility you're getting kind of at the end of time. Because you're sort of pulling everything forward, but then, if T overline is fixed, then however well off we would have been at the end of time, you're just getting a few more years. There's 5 more years there. And we'll kind of roll everything else into something called trajectory change. Okay. So in this framing, Bostrom's basically arguing that 1 is better than 2. Right? And he's just sort of not engaging with the possibility of 3. So here's my kind of attempt to formalize the conditions under which his argument holds. A pair of utility paths will be called asymptotically equivalent if the ratio between them converges to 1 in the limit. And if both paths are, well, you could just say one of them because they're going to, the ratio is going to 1. So, but for some time, they're bounded away from 0, like above 0 or below 0, for all times after that time. So they're not like both approaching 0 ever closer. Ratio is going to 1, bounded away from 0. One example, which is especially relevant to the case where u tilde is a growth advancement from the original baseline path u, would be this one. So let's say the long run population is constant and consumption grows on both paths so that utility rises toward the upper bound u bar, right? Well then, in the limit, at least, well, if we've normalized population, no matter how we've normalized population, the ratio between u and u tilde will be like if there's n people, right, and they're all getting utility u, then they get like nu in the denominator, n u tilde in the denominator. Well, they're both going to u bar, so like the ratio is going to 1, right? So there would be a case where like you've got that upper bounded utility. But another example, which is the one maybe Bostrom had in mind, is let's say individual utility approaches some u tilde, or like, I don't know, the utility we're like squeezing out of each unit of matter, say, if we're like turning it all into computers that are simulating happy lives or something. That approaches some u tilde on either path. But the population, or the resource base or something, is eventually growing cubically as we expand into space at some maximum feasible speed. But expansion begins one period earlier on u tilde than on u, right? Well, in that case, we've got that like, oh, sorry. This should be a bar. Individual utility approaches u bar on either path. But how many like individuals there are, or like units of resources to turn into quasi-individuals there are, is t cubed in the limit on the original path. But it's t plus 1 cubed on the accelerated path. Because at every time we're where we would have been like a year later or whatever, right? So you're getting all this growth. You're getting like the shell of a sphere, right? You've got this bubble growing in time. And if you start growing the bubble a year sooner, then at any point in time, you've got this whole extra shell that you wouldn't have had on the original baseline path. But nevertheless, the ratio of the larger bubbles to the smaller bubble goes to 1 in the limit, because a cubic growth rate is less than exponential. And so that extra year as a proportion of everything you've accumulated already is shrinking to 0, that kind of extra benefit. Okay, the result, the reason why we care about this is that letting S of u, S sub t of u be the probability of no, say, existential catastrophe other than the exogenous one at time t bar, no catastrophe by t on path u. This is the like overall utility produced by path u, given that you live until t. And if two paths are asymptotically equivalent, and your baseline u has some chance of never succumbing to an anthropogenic existential catastrophe, so you make it all the way to t, then as the exogenous end date goes to infinity, then the ratio of the utilities between the two paths just sort of converges to the ratio of the probabilities of survival. Okay? So you basically only care about survival if your options are asymptotically equivalent utility paths. As the time horizon gets longer, the only thing that matters is going to be survival. And so under those conditions, we can rule out the growth type interventions and say, okay, the near best thing, any near best thing has to be either an attempt to lower X risk or raise X risk if, you know, the way we're being bounded away from zero is because like we're below zero and there's just like, it's about whether we get all this like expanding bubble of suffering. Or we should be trying to like affect the probability of X risk or induce some kind of trajectory change that's not going to be asymptotically equivalent, which probably won't look like just like kind of stretching the growth path, but something kind of more fundamentally changing the kind of course of history. All right, so those are some kind of very big picture thoughts. Hopefully they'll be helpful for interpreting some of what comes tomorrow and Friday.